Alright, today is lesson 8.4, and it's actually one of the most important lessons of this unit. It's the elimination method for solving a system. So your aim today is that you can solve a system of equations using the elimination method, which is, I'm going to underline right here, which is what we started to work on in 8.3, where we were, multiplying equations, adding them. So we're going to get into a more official method in this lesson. So in previous courses, you've seen how to solve systems graphically and how to solve them by substitution. So those are the two methods you've learned so far. Today's lessons will build on the previous one and formally introduce the technique of solving a system by elimination. It's our third and final method. Remember from last lesson that solutions to systems remain solutions if properties of equality are used to rewrite either of the equations. That's like where we, multiply or, not multiply, but where we multiply 1 to try and get a coefficient, okay? And then the second part where the equations are added or subtracted. So where we alter an equation and then we can add or subtract in order to eliminate. That's our goal. So exercise 1, I'm going to show you exactly how this entire process goes. So exercise 1 has, consider the system shown below. Notice that in A and B, it's the same system. 4x plus 5y equals 12. At negative 2x plus y equals 8. Part A wants you to eliminate x, and part B wants you to eliminate y. So I'm going to show you how to do this with a different color. So to eliminate x, so here's my x's right here in this column, I need them to have opposite coefficients. So in order to do that, I have to think, can I somehow turn a negative 2 into a negative 4? I certainly can, by multiplying both sides by negative 2. When I do this, the top equation stays the same. I get 4x plus 5y equals 12. In the bottom equation, I have to distribute that negative 2. So I'm going to get negative 4x minus 2y equals negative 16. Okay? Oh, I'm just multiplying it by positive 2. I'm sorry, I made a mistake. I should be multiplying it by positive 2, not negative 2. Sorry. So I get negative 4x plus 2y equals 16. When I do that, notice that now the negative 4 and the 4 are opposites. So when I add these two equations together, these are eliminated, and I get 5y plus 2y to give me 7y, and I get 12 plus 16 to give me 28. Now that I've eliminated x, which is what the directions told me to do, I can now solve for y. I get y equals 28 divided by 7 is 14. Okay? Now once I find y, what do I have to do? I've got to plug in to find x. So I'm going to pick that top equation, 4x plus 5y equals 12, and now I'm going to plug in y equals 14. So 4x plus 5 times 14. 5 times, oh, I'm sorry, I'm doing all kinds of crazy stuff. This should be a 4. 28 divided by 7 is 4. My bad. So this should just be a 4. Sorry, guys. 5 times 4 equals 12. There we go. So now this becomes 4x plus 20 equals 12. Subtract 20 on both sides to solve for x. And I get that 4x equals negative 8. Divide both sides by 4 to get x by itself, and I get that x equals negative 2. So I get an answer of negative 2, 4. So I've eliminated x, I found y first, and then I found x afterwards. The second time it now wants me to eliminate y first. So now I'm going to look at this column. To eliminate y, I need to have a 5 and a negative 5. So to get a negative 5, I'm going to multiply now this bottom equation by negative 5. And that is going to give me opposite coefficients. So I keep my top equation the same, 4x plus 5y equals 12. But the bottom equation is going to become 10x minus 5y equals negative 40. Now I can eliminate these when I add them all together. 4x plus 10x is 14x. And 12 minus 40 is negative 28. Divide both sides by 14 to get x by itself, and I get x equals negative 2, which is the same as I got over on the first problem, that negative 2. Now I have to take x equals -2 and plug it in. So I'm going to pick that top equation again, 4x plus 5y equals 12. And I'm just going to replace the x with a -2 and solve for y. So 4 times -2 is -8. Plus 5y gives me 12. And then I need to add, I'm going to add 8 to both sides. And then I get 5y equals 20. Divide both sides by 5, and I get y equals 4, which is the same answer I got the first time. So I know that I've done this correctly both times. Here. -2, 4. Okay. Now part C says, show the point you found in A and B, that's this point right here, that I'm going to put a box around, this -2, 4. Show that this point is a solution to this system. When it wants you to show, remember that's a fancy way of saying, you know, plug it in. So I have my two equations, 4x plus 5y equals 12, and I have the equation -2x plus y equals 8. And now I'm just going to plug in the point -2, 4 to see if it works. So -2 is my x, 4 is my y. So I have 4 times -2 plus 5 times 4 gives me 12. 4 times -2 is -8, and 5 times 4 is 20, and -8 plus 20 is 12, so it does work in the first equation. Second equation, replace the x with the -2 and the y with the 4, and simplify. -2 times 2 is 4, and 4 plus 4 is 8, so I've solved this problem correctly and checked my work to make sure. This is the elimination method. Multiplying an equation by something, so the coefficients are opposites, they cancel out when you add them together, and then you get a simple equation you can solve, and then plugging it in to find the other variable you originally eliminated. Okay? Let's do some more practice with this in exercise 2. Exercise 2 says solve the systems by elimination and check that your answer is a solution. Now this one's a little trickier because this one's not as easy to get one equation into the opposite coefficient. We can't easily turn a 2 into a 5 or 2 into a 7. So our issue with this one is we've got to multiply both equations. Sometimes this happens. You have to multiply both of them. So the first equation, I'm going to just eliminate my x's. I always try and do x's first. This first equation, I'm going to see the two coefficients. I'm just going to multiply one by the other one, and the bottom one by the top one. So I'm just multiplying them each by the opposite coefficient, and one of them has to be negative, so let's just make the top one negative. So I'm going to multiply this top equation by -2, and I got that 2 from this coefficient, and I'm going to multiply the bottom one by 5. Let's do this in like a different color so I can show you. So this I'm multiplying by 5 because I got the 5 from here. The top one I'm multiplying by 2 because I got the 2 from here. And watch what happens when I do the multiplication out. Watch what happens. This top equation is going to become -10x plus 4y, I'm distributing, equals -20. And the bottom equation is going to become 10x plus 35y equals 43 times 5. 215. Now look what I can do. Now I can add the two equations together because now I have a -10 and a +10 and they will cancel out. So now I can finish with my y's. 35y plus 4y is 39y, and 215 minus 20 is going to give me 195. When I divide both sides by 39, I get that y equals 5. Okay, so the crucial steps was knowing, oh, there's the bell. Sorry guys, that was the bell. The crucial step was multiplying both those equations by the opposite coefficient, right? Now that I've got my y, the rest is easy. I'm going to plug it in to find the others. So here's 5x minus 2y equals 10. That's the first equation, and I'm just going to replace the y with that 5. So I get 5x minus 10 equals 10. Add 10 to both sides, and I get 5x equals 20. Divide both sides by 5, and x equals 4. So my final answer, written as a coordinate, is 4, 5. Okay? The rest of this problem asks me to check that my answer is a solution. So to do that, I have to rewrite each equation. So 5x minus 2y equals 10, and the other equation is 2x plus 7y equals 43. And I'm checking this point, 4, 5. 4 is my x, 5 is my y. So for my x, I'm going to put in a 4. For my y, I'm going to put in a 5 and simplify. 5 times 4 is 20. Negative 2 times 5 is negative 10. And 20 minus 10 is 10. So it does work for our first equation. Second equation, plug in 4 for x and plug in 5 for y and see if it works. 2 times 4 is 8. 7 times 5 is 35. And 8 plus 35 is 43. So now we know it's a correct answer because we checked. It works for both. Okay? This is a really tough lesson, so please make notes in your notes where you want me to, or you want to ask me questions when you come see me in class. Okay? Let's go on to the third exercise. There are many applications of solving a system of linear equations by elimination. One of the more interesting ones comes in finding the equation of a line if you know 2 points. We've done this before in Unit 6, where you've had to find an equation of a line through 2 points. Well, this is another way to figure that out. First, you had to find the slope, then plug the slope in, find the y-intercept, and rewrite the equation. So I'm going to show you a new way of doing that in this exercise. Okay, exercise 3. Consider a line that passes through the points -2, -11, and 3, 14. We want to find the equation y equals mx plus b form. So the first step to doing this is substitute both of the known points into y equals mx plus b to create a system. What that means is you know that -2 is an x and -11 is a y, and that 3 is an x and 14 is a y. If our equation y equals mx plus b, so I'm going to take my y equals mx plus b form, but instead of y and x, I'm going to replace it with my 2 points. So y is going to be -11 equals, I don't know what m is, but I know that x is -2, and I don't know what b is. So there's my first equation. I can rewrite that a little nicer and say -11 equals -2m plus b. The second equation is the 3 and the 14. So let me just do the colors here. So this is like -2, -11, and I'm plugging it in here. -2 and -11. The second equation is this 3, 14. So I'm going to have y is my 14 equals m times my x value is 3 plus b. Written in a nicer way, that's going to be 14 equals 3m plus b. So I've created a system using this x and y values. So 14 and 3. Now I'm going to solve it in part B. Solving this system is actually pretty easy because they've already given you these b's by himself. So I'm going to rewrite them over here. -11 equals -2m plus b, and 14 equals 3m plus b. Now the way I'm going to solve this is instead of adding these two equations together, I'm going to subtract them. And look what happens when I subtract. I get -11 minus 14 is -25. -2 minus 3 is -5m. And what's b minus b? Well, they're like saying 1 minus 1, it's 0. They're eliminated. So you can subtract also instead of adding when the situation calls for it, right? In this situation, we need to subtract. Now we have something really easy we can solve. Divide both sides by -5, and you get that m equals 5. Now that I know my m, I can do what I always do and plug it into the other equation to find b. So I'm just going to pick the first one, -11 equals -2m plus b, plug in 5 for m, and solve for b. So I get -11 equals -10 plus b, add 10 to both sides, and you get that b equals -1. So my equation then, if m equals 5, and b equals -1, my equation that passes through those two original points is going to be y equals 5x minus 1. So it's just another alternative to doing the whole finding the slope, plugging the slope in, finding the b. You can do it that way, but this is an alternative method of solving that particular problem. Okay? Alright, exercise 4. Find the equation of the linear function in y equals mx plus b form shown in the table below. So this one is very similar to exercise 3, but the only difference is instead of giving you 2 points, they give you a table. But can we find 2 points in a table? Yes, we can. So we're going to pick 2 points, and I don't care which one. So I'm going to pick the first 2. So this is a point right here, -2, 3. And we're going to pick a second point. Let's just pick the one next to it, 2, 5. There, I've picked my 2 points, and I'm going to do the exact same thing I did in exercise 3 I'm going to do in this problem. So I'm going to write my 2 equations in y equals mx plus b form. So I have y equals mx plus b, and now I'm just going to write my new equations, remembering that this is an x, this is a y, this is an x, this is a y. So I have the first one, 3 equals -2m plus b, and my second one is 5 equals 2m plus b. Right, I'm getting those from these points here and plugging them in. Now, I'm just going to subtract the 2. So I'm going to put a minus sign, subtract. That will eliminate my b's. b minus b is 0. 3 minus 5 is -2. -2 minus 2 is -4m. Be very careful with your signs when you subtract. Then you're going to divide both sides by -4, and this gives you 1/2 equals m. Now that you know that your slope is 1/2, you can plug it in like we always do. I don't care which equation, but let's just pick the top one. 3 equals -2m plus b. So instead of m, I'm going to put in a 1/2. If my pen will cooperate. Someone is screaming in the hallway. For real. That's annoying. Plus b. -2 times 1/2 will give me a -1. Add 1 to both sides, and you get that b is 4. Now that you know m and b, the equation should be pretty simple. Your equation is going to be y equals 1/2 x plus b. Okay, so a table or points, you can use elimination method to help you find an equation of a line. All right. The last exercise we're going to do is a word problem. The next couple lessons after this one deal a lot with word problems. This is kind of like a warm-up for that. So it's kind of like a riddle, and it's something you've seen before in Unit 3 with translating verbal problems. So let's read. 2 numbers have the following properties. The first property is the sum of the larger and twice the smaller is equal to 13. That's a really important piece of information, so I'm going to underline it. The sum of the larger and twice the smaller is equal to 13. Twice their positive difference is equal to 8. Okay, that's the second part of the problem. What are the 2 numbers? Play around with modeling using variables. So let's make 2 variables because we're working with 2 numbers. Okay, so I'm going to say that let x be the smaller number because one number is bigger than the other. And I'm going to let y be the larger number. And now I'm going to write 2 equations based on those 2 things I underlined. So the red sentence says the sum, well, sum means we're adding. So the sum of the larger, so the larger number is y. So I'm going to have y plus something. The sum of the larger and twice the smaller. Twice the smaller would be 2x is equal to 13. So there's my equation for the first sentence I've translated. The second equation says twice their positive difference. To get a positive number when you subtract something, you have to subtract the bigger number first. So the bigger number is y, so I want y minus x to get a positive difference. And then I'm going to remember I see this word twice, so I'm going to put a 2 in front of here because it's twice that difference. And that's equal to 8 here. Okay. Now all I have to do is distribute and see if I can solve this system using elimination. So this stays y plus 2x equals 13, and this says 2y minus 2x equals 8, and this is really awesome that both the coefficients are opposite, so we can just eliminate them right away. They cancel out. 2y plus y is 3y, and 13 plus 8 is 21. Divide both sides by 3, and y equals 7. Once I know y, the usual, plug it in to find x. So I'll pick my first equation, y plus 2x equals 13. I'll just replace the y with a 7. And then solve. Subtract 7 on both sides. 2x equals 13 minus 7 is 6. And then divide both sides by 2. And x equals 3. So to answer this problem, the two numbers are the one number is 7, the other number is 3. And that's my final answer for this problem. Okay. Mastery for this is on 8.3 and 8.4, so make sure you have both, and good luck.